Numpy indexing. I have divided it into two parts. Numpy indexing for a one-dimensional array and a two-dimensional array. And wherever possible, I will compare it with list so that it makes the understanding easy. Now let's get started with one-dimensional array. And I'm saying let's see the indexing for a single value. What does that mean? Let's first create a list, simple list, lst. I'm going to use the range function and I'm going to create a list which is going to be from 0 to 10. So 0 to 10. This is a simple list. Okay. And now if I wanted to index or find the value of like index number 7, I would simply use this square brackets and put the index number in it. So if I do that, what would I get? I would get the value at index 7, which is 7, obviously. Alright. And similarly, whatever I want to get a value of index like 10, I would simply put lst within the square brackets 10 and you get the values 7, 10 and so on. So this is as simple single value indexing on lists. Now how about numpy arrays? Now let's simply create a numpy array. I'm going to create a numpy array using np.arange and I'm going to say 0 to 11 and then going to print this numpy array. So this is a simple numpy array that we have created. Now I just want to check again the same thing, the value at index 7 and value at index 10. So can I use the same thing, square brackets and the index value in it? Let's see what happens. npa and index value within the square brackets, and I'm running this cell and there you go. So for a single value indexing on a one-dimensional array, similar to what we do on lists, it is same we do on numpy array also. That is using square brackets and putting the index value. Now let's go to multiple value indexing. Now I already have written some piece of code here. So what I'm trying to do here is creating a list same as this from 0 to 10 and creating a numpy array from 0 to 10. I'm going to run this and I'm going to print the numpy array here, which is going to from 0 to 10. Alright. Now, and I am passing a list. I'm passing a list of indices numbers and I want to know the values of those. So you can do that and it is possible in numpy array. But if you do the same thing, trying to find the values of multiple indices by passing a list, it's not possible in Python. You can try these lines of code and try to see if it is possible or not possible. So what I have done here, I have passed a list of elements, lists of indices, and I'm going to get the values. So this is an numpy array with values at index 0, 2, 6 and 8. Alright, let's move on to slicing. Now let's run this cell. What have I just created? I have created, let me print the list and also the numpy array. So these are list from 0 to 9 and 0 to 9 is a numpy array. Okay. Now I want to slice. How do you slice using lists? So you just use square brackets and a colon and it would be from like let's say 0 to 5. 0 to 5 would mean that it's including 0 and until 5 minus 1, which is 4, right? Let's check it out. So let me print here lst and let's see when I slice this what will happen. When I slice this, you get all the elements from 0 to 4. So this one is this. Is it the same for numpy array? Let's check it out. So print NPA 0 to 5. And let's see what happens when we run the cell. Yes, it is same for the NumPy array. So there is a similarity here for whatever we did with respect to lists for a one-dimensional. Obviously lists are one-dimensional. For NumPy one-dimensional array, you do the same slicing operations. Alright, so this is also done. And now let's see another case which is called as updation using slicing. So what does this mean? So let's say you are creating a list and a NumPy array here. Okay, let's run the cell here. Okay, and just let me print the list as well as NumPy array so that you will see it. Okay, so you have this list and NumPy array. Okay, now I want to expand the list. Okay, I want to expand the list. What I am trying to do is I'll say, so this is like what? It goes from 0 to index 10, right? I want index 11 and 12 to have a values of 77 and 777. Alright, and I want to like print the list again here. Let's see what happens. There you go. So you are expanding the list by adding two more elements. You are adding the 11th index and the 12th index, all the way from 11th index and 12th index, and you are assigning these values 77 and 777 to the 11th and the 12th index. That's cool, right? That's possible with lists. Now how about NumPy array? Is it possible? So let's try. So what we'll do is NPA 11 to 13 is equal to 77 comma 777, and try to print a NumPy array. Now what happens is it throws an error. Why? Because it's not possible. It's not possible. Not possible in NumPy arrays. It's not possible. But with lists it is possible. Alright. Now I also want to show something else too. Here, let's say I want to change the values of different indices with a single value. So let's say NPA, and I'm going to say 0 to 7. I want to change it with a single value like 888 or 888. Okay, and then I'm going to print this NPA, and let me see what happens. There you go. So by assigning a single value to a range of indices from 0 to 6, all those values at indices 0 to 6 have been changed to 888. Now can we do the same thing with lists? Is it possible with lists? LST, and I say 0 to 7 and I change it to 888 and try to print the list LST. What will happen? Let's see. It throws an error. It's not possible. It's not possible with lists. Alright, it's not possible with lists. So to conclude, what can we conclude? So to conclude, use in lists you can create new indices on the go and update the values. Okay, and for NumPy array it is not possible. For lists it is possible, and you can update multiple indices. You can update multiple indices with a single value in a NumPy array, which is not possible in a list. So this is simple indexing on a one-dimensional array. Now let's see indexing on a two-dimensional array. Alright, so let's say case 1. In case 1 I have written it, and it says all elements of columns all elements of columns. So now let's say you have a two-dimensional array. I have created this two-dimensional array, simple two-dimensional array. What is this line of code? Say np.arange 1 comma 20, which creates a one-dimensional array starting with value 1 until 20, and now I'm reshaping this. It has 20, right? It has the size of this is 20, and I'm reshaping it to a 4 by 5 matrix. So it has got 4 rows and 5 columns. Alright, so if you see the shape of it, it will be 4 by 5. So if I run this and check out the and print the array and its shape, it is what it is. This is what it is. Alright, so what it is, this is a 4 by 5, 4 rows and 5 column matrix, and this whose shape is 4 and 5, 4 comma 5. Alright, so this is what we wanted. Now what I told, all elements of column. Okay, I want to select or index, or we can say selection via indexing to be precise. Okay, zeroth column, zeroth index column. So all elements of zeroth index column. So zeroth index column is what? This one, right? 1, 6, 11, 16. I just want this 1, 6, 11, 16. I want an numpy array which contains 1, 6, 11, 16. That's it. So all elements of column 0. Then how do I do it? So what I do is I'll take that numpy array underscore 2d, and what I'll do is I want columns, right? So I'll say colon, and then what I'll say, what should I say? So let's say 0. What will happen if I print this? If I print this, what will happen is you get 1, 6, 11, 16. So you got a numpy array with all elements of zeroth index column. That is what you wanted, right? And there is this comma, right? Before this comma it is rows conveniently, and here it is column, 0 column. Now if I want all elements of column 0 and 1, 0 and 1, so obviously I'll take this one, okay, and instead of just 0, I'll use a tuple with 0 and 1. These are the columns, and let's print it out. What happens? So 0 the column and first index column, 0th index column and first index column. So these are the two things, right? First column, second column. So those two gets printed here. Now what about all the elements of column 0 and 4? That's even same and simple what we have done previously. You're just going to modify that code, and instead of 0 you'll say 4. So this is all the column elements, all elements of column, or all elements of column 0 and 4. Let's print it out. See, all elements of column 0 and 4. So this is 0 and 4 is 0, 1, 2, 3, 4, this one. So 0 and 4, these two columns are here. Alright, now all elements of column 0 to column 3. Alright, so you can use slicing here. What it says is all elements of column 0 to column 3, right? So simply 0 to 3, 0, 1, 2, 3, 0, 1, 2, 3, all these elements are included here. So just you can say 0 colon 4. Right, you don't need to put them inside a square bracket here, you can directly write them in here. So this is a simple case of NumPy selection through indexing on a two-dimensional array. So using this, we are selecting all the columns of an array, all the columns of an NumPy array, be it a single column or be it multiple columns at a time. Now how about rows? Is it possible all elements of rows? Of course it is possible, right? So let's create again the same thing using np.arange. I have created a 4 by 5 matrix. So this is what it is, alright, with shape 4 by 5. Now if you want to select the entire row, how do you do this? So it's going to be an easy guess, right? You'll say take that numpy array underscore 2d, and then what you're going to do is, instead of, see, this is left side of the comma is rows and right side of the comma is columns. Now we are going to put colon on the right side, and now what you want the entire row. First row is of index 0, right? Well, let's see what happens. There you go, you got the entire first row. Now you want the 0th index row and the first index row. What does that mean? You want these two, right? 0th index and first index. Okay, fine. What we'll do is we'll just simply copy this and paste this, and we are going to use a tuple which says 0 and 1. Let's print this. So there you go, you have this first row, second row, or 0th index row and first index row. There you go, you got this, right? Now other question is 0th index row and third index row, which is also simple. Just modify this simple code here, and instead of 0 and comma 1 in the tuple, you say 0 and third row, right? 3. Simple. So you get 0th row and this row, third row, 0th index row and third index row. Not the third row, sorry, but 0th index row and the third index row, which is this one. So you get this thing. And finally, there's another question here. It says 0th index row to second index row. That means you can use slicing. That's what it is. So similar to what we have seen in selection of all elements of columns, what you do here is you just simply use slicing. So you say 0 colon 3. That's it. So you get 0, 1, 2, 3 columns, right? Sorry, 3 rows of this numpy array. Okay. Now we have seen a two-dimensional array, and we have seen how to select or index columns and rows. How about combination of rows and columns? Now same array underscore 2d, I have created a 4 by 5 matrix, and see, I want to select 0th element, 0th row and 0th column. Now for example, this is your array, right? Now array 2d of 0 0 would mean 0th row, intersection of 0th row and the 0th column, which would be 1, right? Which would be 1. Alright, so now one important point here is, so this is your array underscore 2d, right? This is your array underscore 2d, and then array underscore 2d of 0 comma 0 is what? Is 1, right? Also array underscore 2d of 0 and 0 is what? It's also 1. So what am I trying to tell you here is array underscore 2d of 0 comma 0 is same as array underscore 2d. It's just a representation. It's a way of representation. You can use this, or you can use this. Now what will happen is these two both are same. These both are same. This and this are same. Now if you want to find the, let's say, this value, right? So this is like what? 0, 1, 2, 3, third row, and 0, 1, 2, 3, 4, 3 and 4. Okay, so let's say array underscore 3d, and I'll say 3 comma 4. What will happen? Oh, sorry, not 3d, 2d. Sorry. Okay, 2d. What will happen? It's 20, right? Instead of this, if I simply say 3 and 4, what will happen? You also get the same value, 20. So it's just a way of representation. Okay, let's get back to the combination of rows and columns again. So we have seen that these two are the same things. Okay, now I have told you before the comma, left side of the comma is something and right side of the comma is something, but when it comes to the combination of rows and columns, and you're using tuple on the left side and you use the tuple 0 comma 2, which would mean 0th row and second index column, and second index row and fourth index column. So I think this needs correction here. Okay, now so what does that mean? So I want 0th index row and second index column. So 0th index row and what 0 1 2 second index column. So this would be 3, right? 0th index row and second index column would be 3, right? This would be 3, and second index row and fourth index column. So 0 1 2 second index row and fourth index column, 0 1 2 3 4, that would be 15. So we are looking for values 3 and 15. So this one, entire one, would give a NumPy array 3 and 15. Alright, and how about this one? When you're using slicing, it's just the intersection. What am I talking about? So it says like 0 to 0 colon 2, that is 0 1, right? 0 1, 2 columns, 0 1, and 0 1 rows, 0 to 1 rows, 0th index row, 1 index row, this one, and intersection of 0 to 1 index columns. So 0 column, 1 index column. So 1 to 6 7 is what you're looking. So 1 to 6 7 is what you're looking. Similarly, if you say 0 is to 2 and 2 is to 4, 0 is to 2 is like this, and 2 is to 4 is like what? 0 1 2 4. So 2 3 4, 2, sorry, not including, right, excluding 4, so up to 3. So second index and third index. So this is 0 index, this is 1 index, second index and third index. So 3 4 8 9 is what you will see when you print this, 3 4 8 and 9. Alright, so this is all about NumPy indexing, and we have seen that we have indexing via one-dimensional array and two-dimensional array, and we have seen subtypes of all these things. Thank you.